start with these different layers of cake. This is the beauty of what we're doing, that each of the components can be treated separately. So if you like the icing, you will eat only icing. And if you like the crust, feel free to grab some crust. But in the end, it also depends, as you say, how you slice the cake, I would say. So take only what you need and maybe just customize it a bit. Like for my kids, some of them like fruits on the cake, some of them are not. So I suppose I have the ability to customize it to specific applications. And thanks to the service-based approach, like service-oriented architecture in which we develop that, we integrate different layers through REST API, for instance, and we can use them separately as standalone applications.
So, welcome to another episode of the AI and Digital Transformation podcast brought to you by GMSC Consulting. So, in our podcast, we talk to experts and ask them to share with us the different use cases they've worked on related to AI. For today, our guest is Marek Tatara, the Chief Scientific Officer of DAC.Digital. Of course, together with me is my co-host, Gabriele.
Hello, everybody.
So, hi, Marek, and welcome to the podcast.
Hello, thanks for inviting me.
Before we begin, I think you can briefly tell more about yourself, and then we can also then discuss further about the use case we've chosen today.
Certainly. So, hello, everyone. I'm Marek Tatara. I'm Chief Scientist at DAC, as already you heard. I'm working at DAC for over 5 years. I'm currently having 2 T-shirts at DAC. One is being the supervisor of all the R&D initiatives that we have at DAC in terms of proposal preparation, but also in terms of implementation. And I'm also tech lead of the AI team. And I'm working on commercial R&D, but also engineering projects related to AI, computer vision, and embedded systems, and everything conversion.
So it's great to have you here, Marek. And you actually bring to this podcast a very interesting topic, which is AI in manufacturing. This is especially interesting because, as you know, our headquarters are in Genoa, Italy, and Italy is after Germany, the second biggest manufacturing country in Europe. A big share of our economy is dedicated to manufacturing, and yet there's a little awareness about the AI application in this field. So the solution we'll discuss today is about machine learning operations in manufacturing. But first, maybe you could give us some insights about the applications of AI manufacturing, actually.
Okay, maybe I'll even give you some background why I'm interested, why I want to go into manufacturing, because I got PhD from diagnostics of processes, from industrial processes, in particular leak detection of industrial pipelines. So in there, I studied how to employ digital twin for real processes, how to actually use that for monitoring, and what are the benefits that can be brought along with employing the model-based approach to the manufacturing. There are other approaches, data-driven, but actually having that, we can know whether everything is operating as it should. We can detect some theft. We can go for predictive maintenance as one of the applications for manufacturing, where you have a production process, and after some time, your machine breaks. This is obviously a cost to you because you stop the production. You don't want to stop you don't want to stop anytime. Basically, you want to continue the process. If this is predictable, deterministic, you are able to plan ahead, know how many components you can bring to the customers. And if something breaks unexpectedly, these are costs for you. So this is one of the applications that is kind of popular in manufacturing and helps to reduce the costs related to normal operations. Another applications that I can enumerate, for instance, quality assurance using computer vision, where you have employees that are looking at specific components or testing them. Well, after 8 hours looking at the same component, you can get tired, you are fatigued, and, well, you can't really focus the same as at the beginning of your work. There are plenty of other applications bringing robotics to cooperate with humans. For instance, as another applications, you have to integrate various various sensors that let you automate the entire process. This is one of the things that comes forward and is a trend in manufacturing. You can go for anomaly detection, which is kind of connected with quality assurance, but you can employ it on different parts of the production process. Maybe you want to measure specific parts of your manufacturing process to know the model of your production plant better. I saw different applications for going into digital twins of factories, entire factories, to optimize the placement of specific robot stations to actually reduce further the time of manufacturing specific parts, components, systems. So this is something that comes to my head first. There are also safety applications, thanks to computer vision monitor, when there are some virtual barriers that are not crossed by machines or humans, which can be critical from the viewpoint of safety, can harm people. There are plenty of innovations that can be brought into the manufacturing. Most of them are related to reducing costs, engineering costs, bringing the revenues, innovating the processes, making things faster. But there is also another branch that is focused on sustainability, reducing the energy consumptions, costs related to that, but also becoming, well, greener.
Yeah, a lot of applications, and sadly, not many people know about it. So it's great to discuss about it, especially in Italy, where most manufacturing company are like middle to small size, so they're not really into this kind of innovations. But there's not just a life cycle of machines. There's also the life cycle of machine learning algorithms, and that's where what you're working on comes in. So could you tell us a bit more about where's the added value in a machine learning operation tool? And specifically, why did you choose to go for a custom solution rather than going on something that's already pre-made of easily customizable?
That's a great question. I see machine learning operations as interesting research area because right now there are different definitions of what is machine learning ops. Sometimes we employ a solution for dataset monitoring, like DVC, that is out of the box. And we can say, okay, we're using MLOps. That's all right. There are different definitions, and it all depends what is your goal. We are trying to approach it more comprehensively. From one point, we want to have the means to speed up our internal development process. We are working on custom machine learning models. We are aiming at edge deployment, so we want to incorporate the optimization of the models in such a pipeline. But also we want to have comprehensive approach to model monitoring and versioning, dataset versioning, experiment tracking. There are tools that we use, but we try to assemble them, go to the next level at another logic layer to have it as actually low-code solution or even no-code in some cases to take advantage of cloud solutions where we can run multiple trainings on various data sets and see what actually gives us the best outcome. This is for the development time. We also implement the qualitative tests for the models that we have. We know on which data set it was started, what was the outcome, what are the metrics. And thanks to that, we can reuse the same test for production monitoring to run some nightly tests on the models and see whether they perform as they should. To be sure that we still achieve the same metrics. Moreover, we were interested whether how the data sets that we use are related to the target environment. So that's why we started looking not at the models, but at the data that are on the production. If we see that the model is not performing well on the production, even though the qualitative tests say differently, then we know that probably there is difference, this is our hypothesis, difference between the target environment and the data sets we used for training. And then we can characterize the data that we have on the production and see whether there is some data shifts. The characteristics of the data is kind of different. For that, we usually employ analytical methods to characterize the objects that we have in the image and see whether it's adequately represented in the training data set. If we have two different data sets that we use in training, in production, then it may not work as we expect it to be. That's why we wanted to take a look at this on one hand from high-level view to get the control from the development time through deployment production, but also to provide tools for the production time to be able to determine what's wrong if something is not working. There is another layer that we like to use, the explainability layer, that lets us to see on the production data why this model takes the decision as it takes. We can take some of the features that are most critical to determining that this is this kind of object and see whether it will perform, it will be still robust to detect correctly what we aimed it to be or classify the images correctly. And having our own solution here lets us have a better control over the entire chain, entire life cycle. This is on one hand, but on the other hand, we can also implement new functionalities that are experimental on us and know where to plug them directly and see what's the benefit they bring. We use the same data versioning schema, add experiments that we perform to our tracking dashboard and see how it performs. So we have everything in one place.
That sounds like, I don't know, like very complex. It's like building a very nice cake.
Yeah.
You have layers and layers, and then it's like
very tasty.
It should be tasty too, but like it's if you mess up one layer of the cake, the whole cake doesn't come out nicely or doesn't taste nicely in the end. It's like you have to be careful to do one thing at a time. I don't know. This could be a question for both of you because I'm not so familiar with MLOps. Like, do you have to do one thing at a time, or do you would rather have like teams, different teams doing different tasks and then talk to each other and understand how to go about in these different phases?
Let me take that one, if I may. I will start with these different layers of cake. This is the beauty of what we're doing, that each of the components can be treated separately. So if you like the icing, you will eat only icing. And if you like the crust, feel free to grab some crust. But in the end, it also depends, as you say, how you slice the cake, I would say. So take only what you need and maybe just customize it a bit. Like for my kids, some of them like fruits on the cake, some of them are not. So I suppose I I have the ability to customize it to specific applications. And thanks to the service-based approach, like service-oriented architecture in which we develop that, we integrate different layers through REST API, for instance, and we can use them separately as standalone applications.
Another interesting part of the project is that it's actually a European project. Correct? It's like European funded. So,
correct.
I was wondering whether like the outcome of the project, all this code, is going to be somehow released as an open source tool that every European country can use to boost their manufacturing, or if it's somehow only shared among the companies joining this project. Do you have any insight on that? Because it could be very useful for our listener.
Yes, I will start with that this is co-funded project. So some of the investment is covered by the companies that are participating in the projects. We have industries, we have small, medium enterprises, large enterprises in the project. So depending on which type you are and from which country you come, you have different type of co-funding, different level of commission of your national funding. So there is still a part that you have to invest to develop something, to clarify how it works. And relating to the open source part, this is something that is always considered in such projects, because especially when we have universities, they are interested in research. It's usually being published. So this is the base level from which you can take the knowledge and see how it's implemented. We as a company also publish as a part of these projects, because we see the value added in sharing the knowledge. If we did something interesting, we know that through publications we reach more people, we spread our idea, but we also have the opportunity to have interesting discussions. We have feedback, what can be improved. We get more collaborations. In terms of open source, there are a few components that are planned to be developed as open source and are available some of them are already available to the public. One of the underlying parts of the project is, for instance, digital reference ontology, which is open currently, and everyone can use that. This is like big ontology that describes the semiconductor manufacturing process and related parts of the process, supply chain, production, and other aspects that you can encounter in semiconductor manufacturing and supply chain. And there is focus of the people that are working on certain technologies to use it or publish it as an open source. Another example is Eclipse Arrowhead, that is being developed as a framework, as a part of the project. It was developed in previous project. Now it's extended towards AI applications and in applications to manufacturing in particular, thanks to this project. Set of AI methods that are being developed as a part of the project is being published as open as well. So there are certain parts that are used only internally for the companies, but we believe that certain and big part of the project, especially the high-level, big-picture technology that can bring benefits to other European or even, let's say, worldwide countries' manufacturing plants, is being published as well.
Well, that's going to be interesting to see the outcome of it and check the research results. So this leads me maybe to one of the final questions, which would be like, what do you think, where do you think is the tipping point between, okay, I will just make my model, build maybe some essential ML tools and release my manufacturing AI tool, And on the other side, no, I need a full-scale MLOps framework infrastructure dedicated to manufacturing. Like, what do you think
it's a thin line.
the threshold stands? Because many companies at some point they have to decide, right? Will I go for something custom and easy and simple, or no, I need to do everything well and build like organized, generalized, or structured framework?
You also have to consider many companies are oblivious or have no clue about the budget.
Yes, exactly. So this is actually very important because we try here, right, to help small companies and the technical managers in those companies decide what to do. So I think they're going to be presented sooner or later with this choice, like, okay, let's go for a small project where we just test something out, or now we really need to take this industrially serious and make it a big pipeline. So where do you think the threshold lies? What kind of advice would you give to some technical managers manufacturing a small manufacturing company that are charged with deciding what direction to take?
As you said, there is a thin line. Indeed, this is not easy to answer, but I will try to scope it as I would approach it in a generic case. So first of all, if you are used to use various components of MLOps like dataset versioning or experiment tracking, this is something that, well, you do automatically, like for software development, CI/CD. You can work without automated tests, but still it helps you to know that something is working. You commit the code you see on your GitHub, GitLab, or wherever you are deploying that tests pass, and you feel better with that. So I think if someone is working on new models, have some experience, will utilize some of the good practices in the model development, so it comes along with even smaller projects. If you have everything set up, you have a template, you know how to start, you know the tools, it's not that much overhead to get started. And usually, if you are even a small manufacturing company, medium, or even big, you don't want to invest too much at the beginning if you don't know it will work. So we suggest usually to start with a proof of concept, smaller project that will just show it works or it can work. It won't work in all the cases, definitely, but it's a short time project that will let you implement a base model. If you start with dataset versioning, at least experiment tracking at this stage, as I said, it's not much overhead and you can do it at the beginning. If you don't have expertise, it will take you some time to ramp up, to know the tools, know how to work with them. But if you are used to work with that, then you cannot live without it. Actually, it makes your life easier. Going further, for bigger projects, again, I would start with MVP, not go to a full-blown scale. And I assume even for large industries, they want to have some proof that it will work before they invest bigger money in a specific project. So starting with proof of concept or MVP is something that seems feasible in all the cases, no matter the size of your manufacturing plant of your company. This always gives you the feeling that you're heading the right direction. And if you know what you want to test, what you want to achieve, it's not that difficult to scope and do it as a, let's say, fixed price project, especially the proof of concept, because if you know the data, you know the business objective, well, it's kind of work, kind of experimental, but still it gives you the feeling if you're going into the right direction by some implementation of some well-known methods, models. You can go for further experimentation later on. If you see, okay, it will work, it's not the most accurate solution, but we can get better by changing the architecture, maybe working on the data set. then you can invest more money in the project. But starting small is something that feels natural, and having a roadmap ahead also helps
Makes
you to
sense.
scope out the proof of concept that will really work. Also, maybe one advice related to that, sorry to continue with that, but I think one thing that should be considered is also scoping right, because there will be edge cases that you cannot solve, and starting with a focus on one thing, one concrete specific case that you want to solve helps really.
Yeah, you should have a bit of strategy, like not be very impulsive. I think that's the message I'm getting.
It's not just a strategy. It's really that for a lot of, let's say, customers or clients, and I see this like every day in my practice, they are used to treat software as a deterministic tool. Like, I will give you the requirements and you will get a solution. And what it's hard to communicate at first is that AI is an experimental science. It's not like deterministic. So you don't know beforehand whether something is going to work or not. In a way, it's more similar to medicine, you know? It's like, you see a patient and you use your experience and your education, and you say, okay, given your symptoms, I know that this cure will probably work with this kind of degree of effectiveness, but in the end, you need to test it out. And also, you cannot have the silver bullet, right? The solution that solves everything. So actually, usually what happens is that the clients come and says, oh, okay, I have this great idea. And usually they lay down an idea that would take millions of euros to solve, right? And some cannot even be solvable. You're like, okay, awesome. But let's sit down. Let's put some things clear. This is what you can reasonably achieve right now. But we need to test it out. So let's try to see where the real business value lies, because we cannot do everything. And we cannot do everything at first in a 50K POC. So it's like, that's like everyday life in the first stages. It's like, because,
I know what you're saying.
You see, you feel my pain.
Yeah. So AI should be done from a medical approach, like starting with small doses, not like NASA where they go, whoa, big immediately.
Yeah, in a way, they're all like kind of experimental projects. It's like you don't really, you cannot fully guarantee the outcome without testing.
Yeah.
And
it's engineering yet again. So.
No, but it depends. I mean, if you make a circuit board and you know how it works and you know that what you can do and what you cannot do. In this case, since it's in a way it's statistical tools, you cannot fully know it before you do it. And that's really hard to communicate. And and communicating the usefulness of machine learning operation tools, it's especially hard in the beginning, because you're already telling them, look, I cannot guarantee what can work and what no. And plus, you also need to have all of these side tools. So I actually really agree with what Marek says. Like in the first iterations, just do something very scoped, very narrow, very simple, and with as little side tools as possible, clarifying that it's like a POC, so it's not something that will be used for years in production. And then from there, when problems start to arise, then those also carry the motivation to implement additional tools, because there's like in all these projects, there's an educational component that must go along with the implementation. At least this is like an experience. I don't know, what's your take on that, Marek?
Yeah, I agree. We can use the cake analogy here. You have to make the crust to put other layers on top of that. Or if you have a cake, you want to eat only just one piece. You cannot eat all the cake. Otherwise, you have not really good experience with cake.
Digestion.
Yeah. I just have a couple of questions before we let you go. Do you think, because this is a European project, do you think at the end of the project, like, we get to see the results, or people get to read the results of like how the impact of MLOps would be? Because it's something that's, I think, invisible for people when you say, oh, there's the MLOps, there's the thing that you have to maintain, and then people don't get to see it.
Well, I mean, certainly there's our podcast. We're making it more obvious.
Yeah. Not like, the impact with the numbers and everything, because there are some people who like to read these kinds of reports. And I guess since it's a European project, people will get to read at the end of the day when the project ends, these reports. And then the last question is, it's not very technical, but what book would you recommend? Which book would you recommend to our readers? Whichever book you like to recommend.
Okay, I will start with the book. It's not the freshest one, but it gives you a great basis, especially for control engineering and theory, which is by William Brogan. It's, let me find the title, Control Engineering, Modern Control Theory. Yes, that's the one. That's my favorite book. It's scientific, but I recommend reading it. It's very nice for scientific one.
So nerds.
The second question in terms of
nerds out there, listen to this, and you have your beach lecture for the beach reading for the summer.
Yeah. Yes, I hope you will grab one.
Well, most likely, it could be. It could very well be. That I am that type of nerd. So
great. Then I fully recommend to everyone. And going further, in terms of impact, this is something that is being done throughout the project, and I think there will be one of the publication at the end of the project that is public and shows the impact in specific use cases that are specified as a part of the project, show the plans for further exploitation of the results, how they can be utilized. There will be some success stories based on what was developed as a part of the project. And with all of that, we try to provide the numbers that show what kind of reduction of engineering costs we can achieve, for instance. What kind of increase in sustainability we achieved in specific use cases, and how this technology that was developed as a part of the project. For instance, MLOps is one of the technologies that is being developed, how it affected the businesses, the companies that are in the project or are associated, and how it changed the way they approach the business, how they operate, and what are the benefits. And of course, how it can be used broader, because this is also on our plate, let's say, to know how we can utilize further the results, not to use them only internally, but spread the word and have something that can be reused in other industries, in other manufacturing plants, so we can bring the innovation to the European market and beyond.
Wonderful. And so let's, I don't know, we might quote Trump and say, misquote Trump and say, let's make manufacturing great again with machine learning operations and AI. And thank you for having been here with us, Marek. Really interesting conversation. So for our listeners, I hope this is an enjoyable beach listening, and if they want more, they have the beach reading. So what more to ask?
And for people who are interested to contact the AC Digital, or if they want to ask more questions to Marek related to what we just discussed, feel free to reach out to the contact details we'll be sharing in the show notes.
Thank you again. And
yes, thank you for having me. Thanks for the nice discussion.
Thank you.
Thank you. Bye, everybody.
Bye.
Thank you. Bye.